All right, let's look at the next one. We have f of x is equal to 3 to the power of x. And again, we are going to identify our growth or decay factor because it's going to be connected to our exponent. So that makes 3 our b. And because 3 is greater than 1, this has to be a growth factor. And now I want to find my initial value a. And again, a and b are being multiplied, so I have to think, am I multiplying by 1 or by 0? And hopefully you said 1, because if you multiply 3 to the power of x by 0, it's going to turn into, everything over here is going to turn into 0. So a has to be a 1, which a is also my y-intercept. So I am again crossing the y-axis at 1, so I now can plot that order pair. And before I can find my asymptote equation and my domain range, I need to sketch my graph. So I'm going to clear my calculator. And I'm now going to go to y equals, and I'm going to type in 1 times 3. Remember, I put my 3 in parentheses. If I don't, it's going to look like 13 to the power of x. And I don't want that. I just want 3 to the power of x. And now I'm going to go to my table. And now, oh, I see some good points. 1, 3, 2, 9. And then 327's off the graph. Again, we're going to connect these ordered pairs to show that we are not skipping or leaving out any x's. This is not a discrete domain. And then I want to see what happens when my x's are negative. So 0.33, 0.1, it looks like they're getting really, really small, almost like they're getting close to 0. So I'm going to, again, draw this graph where it flattens out close to the x-axis as I can. It's never going to touch, which tells me that that's where my asymptote line is. So I'm going to go ahead and highlight this asymptote here, that invisible boundary line that it's never going to touch or cross, even if it looks like it in the calculator graph. So this is my asymptote. I'll label it. And then I know that that is a horizontal line. And that's going to help me figure out my equation. Remember, horizontal, m equals 0 for the slope, and then the y is to help me remember that it's a y equals equation. All right, so I know it's going to be y equals. Now I just got to figure out what is that y value that is going to be the same for that entire horizontal asymptote. And I know if I'm on the x-axis, which is where my asymptote line happens to be, that every y value on the x-axis is always 0. So my equation is y equals 0. Now please do not assume that the asymptote line is always the x-axis. You need to look at your exponential graph and see where is the y value that it's flattening out to. It is not always going to flatten out to 0 on the y-axis. You need to look at your exponential function. And now that I have my graph sketched, I can now find the domain and range. So domain, how far left? Well, it flattens out and it's going forever in the left. So now I'm going to go ask myself how far right, and I run into an arrow, and this arrow tells me not only is it going up, it is also going forever to the right. So because it's using all the x values to the left and all the x values to the right, I know that my domain is all real numbers. And if you don't want to write those 3 words out, you can certainly write that double R to represent the words all real numbers. Okay, so now I want to find range. And the 2 questions I need to ask is how far down and how far up. So I'm going to start with how far down. And it goes as far down as the asymptote, because remember, it's never going to cross it or touch it. So this is going to be y is greater than 0. And again, no bar because it never touches the asymptote. So it's not going to have a solid line or point on the asymptote boundary line. And then how far up? Well, if I run into an arrow, it never stops going up. So now I know that my range is y is greater than 0 for this exponential function.